Welcome. I'm Bret. Welcome to my talk. I'm going to talk about Node.js and Docker today. And all the slides are going to be over here. And that's a full actual bunch of examples. It's a written explanation of a lot of the things that I'm not going to have a chance to go deep into. But my goal today, well, I've got a lot of goals. Let's go through them real quick. Today's talk is focused on the builds, the Dockerfile, the base images, and things you're going to do in the Dockerfile. If you want to learn more about the compose stuff I do with Node and also the automation with GitHub Actions, check out all that stuff in the repo, including multi-arch builds and cool stuff. Turns out finding the best, securest, smallest, and supported by the Node team image is quite complicated. It actually isn't as easy as we all think it is. So I want to give you some of the details so you can make a better choice. Then we're going to go into Dockerfile best practices. Node shouldn't be used as a PID1 inside of its container. So we're going to talk about that and what that really means and what you should use. And then lastly, we're going to have time to talk about multi-stage builds, which I'm going to go into a bunch of examples, I think 3 or 4 of them, and really break down how the stages are all going to work and what I do for my clients and recommend to my students and for all of you out there. But first, let's focus on the base image and exactly what we have to get into to understand what's in the image and how we make choices with all these different options out there. Now, the reality is that there's way too much going on here for me to get even in a half an hour conference talk. So there's more details in the repo. I actually break down my decisions, talk about the different options in more in depth. But here we're going to go through it pretty quickly. Again, that is going to be over at bret.show/DockerCon22. There's a table that I made of, I consider the major options for which Node image. And you might just be thinking, well, why don't I just pick Node:16, which is the current LTS version of Node? Well, not that you necessarily need to read through this whole table, but it's one of the biggest images with the most vulnerabilities. It actually has nearly 2,000 vulnerabilities, CVEs I'm talking about here, that are found with Trivy, an open source scanner, in that. So we don't want that for production. In fact, I don't use it at all. I don't recommend people use it. I only use slim variants or better. So this is really talking about the official Node image, right? So at Docker Hub, you just look up Node, the official Node. There's at least 3 or 4 major choices you can make in there besides just versions. And I'm not an Alpine fan, at least when it comes to programming languages. Alpine is a great minimal distribution. There are a lot of people that are fans of it, but I have many reasons. A few of these major reasons why is the first one here is that the Node team only considers it experimental, not giving it the true tier 1 support that they give standard C libraries that come with things like Ubuntu, CentOS, and Debian. It turns out that when you compare slimmed down Node Debian instances of a container image, they're no smaller, really, they're no bigger than the Alpine image. In fact, if you go with distroless, which we'll talk about in a second, it's actually smaller than the Alpine image. So size isn't a reason to pick Alpine. Secondly, it is 0 currently on the CVE scanner, so it has the least number of vulnerabilities. But if you choose some of the slimmer options that I prefer or distroless, you're getting near 0 as well. We're talking 10 or so, 10 to 15 medium or low, and then maybe 1 or 2 highs in that case. Another reason is that the apps in APK is the Alpine package manager. Those packages aren't pinnable. If you change Alpine versions, or even if you just hold that pin for a while, the next time another version comes out, your version may fall off of the package manager. So you may end up with broken images, or well, you will eventually end up with broken images if you pin versions there, and you should always be pinning versions on your app dependencies for the OS. Lastly, there are many prod fail stories. I have had multiple ones myself of issues in prod that were Alpine specific on Node that I couldn't fix unless I just switched to Debian or Ubuntu or CentOS. Now, you should never, other than maybe your first day in Dockerland, use the Node latest image. It is there for convenience only, in my opinion. It's there for people to get started with the simple examples just to get used to Docker. But there are tons of packages in there that don't belong. There are packages in there like ImageMagick or Subversion, the old version manager, or Mercurial, these version managers that very few people use anymore. There's all sorts of libraries and things in there, which is why it has nearly, at this point, over 800 CVEs in the one image. And of course, you've heard my opinions on Alpine. I mentioned Node 16, nearly 2,000 CVEs, even worse than Node latest. So we just want to stay from that as well. Now, I always use even numbers of Node. Those are considered the long-term stable releases. So 16 would be what we'd use right now. 18 is right around the corner. I would recommend Slim, but in this case, a little known fact about Node. So this isn't true of necessarily every application on Docker Hub, but when it comes to Node releases, when a new major version ships, like Node 18, when it comes out, these are all based on Debian, and it's a very slim Debian release, and then a bunch of stuff is added on, right? But the major version of Debian that's out at the time, that's the long-term supported version of Debian, that is the version that Node will pin to. In this case, we're currently doing Debian 10 in this image. Node 16 Slim is using Debian 10. But the Bullseye release is actually the most current Debian. That's 11, Debian 11. And you can't use that in the Node 16 Slim with this particular tag because when Node 16 first came out, it was pinned to Debian 10. And for stability and to make sure that they don't break people's apps by changing the major underlying distro version, every Node 16 by default here, will only include the Debian 10. Now, the bad thing there is this means there's 131 CVEs because of an older release of Debian. But the good news is they have that tag. So you can update your Debian 11 distro to be your Node underpinnings in your official Node image, but you have to manually select it in the tag. And if you look at a lot of the different versions of Node, you'll notice that they'll mention Buster and other versions of Debian, and that's what those names are. They're code words for the Debian release, and you want that to be the newest because the newest is going to have the most up-to-date apt package manager stuff as well as the least amount of CVEs for those distros. Now, really quick, there are a few other options that aren't the official Node images from Docker Hub, but I think they're even better if you're willing to take a few extra steps to get there. One of my favorite ways to make my own Node.js base image is to really just use Ubuntu. It's my favorite distro. It has that right combo of secure. They actually have less CVEs historically than Debian. They tend to patch things faster, I guess. And they are widely used on the internet. So whenever you're on Stack Overflow or some support site getting help, you often will find answers based on Ubuntu. Now, there's at least 3 ways I can think of to do that. So let's break those down real quick, and I'll tell you which one is my favorite. Now, the first one is just to do apt install Node.js, but the problem is that it installs Node 10. Ooh, that's wicked old, not supported anymore. Next up, if you go to the Node.js website and you find the official way to install distributions in Debian, they use the node source packaging. Now, node source is great. They've been around a long time, and they are key to the Node.js community. However, there is one fatal flaw for me that prevents me from recommending this because it installs Python 3. Python 3 minimal and a few other packages are installed when you use the node source Debian package, which can add additional CVEs. The whole thing I'm trying to get away from here is having unnecessary applications or binaries sitting there in my Node apps. I want it to be minimal. I want it to only include Node and the things that I need, not Python 3. So I won't be doing this. You could, it may not be a big deal to you, or you may even need Python minimal, and that's fine. For me though, I think my favorite way right now, and I've been using it a few years, is to copy in from one image to another so I get just the Node parts I want in the base image I want. It's kind of what you would do if instead of the Node official image being based on Debian, if the Node official image was based on Ubuntu. And all I'm doing here in this example is I define the Node version once at the very top by doing a from line. It just means that the base will be downloaded, and I'm defining it as an alias essentially here. I'm using as Node so that when I use it 3 times later on in this file, I don't have to specify the version each time. It basically keeps it dry. Now, what I'm doing here is I will switch from Node straight to Ubuntu without doing anything in the Node release. That probably should be a 16.4.2 Bullseye Slim if I'm keeping track of my previous recommendations. And then I'm defining the Ubuntu version, which, if you didn't know, you can make them date-based. So Focal would be the 2004 release. That's the code name for it. And then I'm defining the release. They release a new one about, I don't know, every 3 or 4 weeks. And then when you update, you at least in here, what I really like is you know the date that they shipped it. So that has to do with whether all the packages have been updated and the latest security updates. So I update this regularly in my Docker files, pinning it to the latest date version that Focal would be on. And then I'm going to copy in the 3 major locations of all the node stuff. You could really probably get away with just user local. There's not really much else there. Maybe 1 extra megabyte or half a megabyte of files. It's very small. But you would just do that there, and that's bringing in all of the node binaries, libraries, everything you need for Node with nothing else, nothing extra. And if you didn't know about Core-Pack is a new way now to enable and disable all the package managers, including Yarn, the npx, which is complementary to npm, and then the pnpm, I don't know how you say that one, that package manager as well. So you do all that with a Core-Pack enable, and I just do a disable first to make sure that it cleans up all the symlinks, and then it recreates them all without giving me an error about some are already here. So I basically remove them all with disable, add them all back in to make sure the symlinks are correct. And that works for me well. That actually doesn't add any more vulnerabilities on top of the Ubuntu package, which if we were counting is 0 high and critical at this particular day and only 15 medium and lows. So that's really great, considering that I'm comparing it to something like Node 16 Bullseye Slim, which on the same day that I scanned, it had 12 highs and 74 mediums and lows. So quite a big difference in my eyes. Now, to get the total CVE count lower, you can use DistroList. Now, you may have heard about DistroList. It's from Google. It's a project from Google. It's on GitHub. And what they do is they use Debian releases. They take the files from Node, and they, much like I do, they take the binaries downloaded from an official source, and they remove everything from the Debian release that they can, including shells, package managers, you name it. It's all gone. In fact, what's crazy about this release is that it's only 1% of the number of files that the other ones have. It's 2,000 files in that, and when the other ones have 180,000 files usually. So it's an extremely small number of files. However, it doesn't do a lot of things that I wish it did. So because it doesn't have a package manager or a shell, it can only be the last stage in your Dockerfile. Here, what you're seeing is the last stage of a particular Dockerfile where I might use a standard official Node 16 Slim for my dev and test. And then when it really matters, when I'm going to production, I change out for this distro list release where I'm using their URL. You would see at the very top, I'd have a distro line that defines the version. And then I would copy in from source and base, all the stuff that I need. Basically, I'm copying in all my node source files, and then I'm defining all my other environment variables, because now that it's a new base, I have to redefine all my things, including environment variables, what user account I'm using. I have to recreate the working directory, all that stuff. And then I'm able to run my app. So supposedly this is way more secure. I have opinions, and I'm not convinced, because while it does remove what could be potential sources of vulnerabilities, and it definitely reduces the file count by leaps and bounds. But it seems that most of those files weren't really harmful to begin with, because a CVE scanner took me from 15 to 13. So it only really took away 2 other vulnerabilities. It actually added one back that was a high from Debian, because this distro list solution is based on Debian, the same one that has all the bugs in our regular official Node app. So I actually go back and prefer the Ubuntu one, but this is an option. If you're someone who wants to stick with one distribution and you like Debian and you want to stick with closer to the official releases, or if you like the idea of not having a shell and a package manager in production, even though those things may not be what actually makes the app vulnerable, you can do that. And this is a good option, but it makes it a little bit smaller. It's now the smallest. This is actually technically smaller than Alpine. This is 108 meg, this image, which is slightly smaller than 111 meg. So we're saving a whole 3 meg by using this distro list over Alpine. And Alpine, even though they talk about it being slim, it still has 180,000 files in it. So not so minimal Alpine. So here's my official recommendation list. The easy one on top, use the Node Bullseye Slim. That gets you closer than anything else in the official Node images. Then you can use Ubuntu 2004, which is even less vulnerabilities, and then add Node.js in the way you prefer, or go distroless and use Google's. Another limitation of Google distroless is that you could only pin to major versions, which to me is, again, a non-starter. I want to be able to pin to at least the minor version. Usually I want to pin to the patch version because I want to have reproducible builds. I want these deterministic Docker files where if I build it 2 months in a row, I'm getting it all the same exactly every time. Okay, we're done with base images. I know that was a little bit of more information than you maybe needed, but there's even more of that in the repo if you want to see all the links I went to try to find what truly is the most secure, smallest, but most useful Node image. Now let's just get into Dockerfile better practices that may affect you Node.js people. I say better here because best implies that there's nothing better. And in this case, I just know that I prefer these things, but that doesn't necessarily guarantee they're the best for you. Now, you know about Docker ignore, right? So Docker ignore is essential. I just copy the gitignore file into a Docker ignore. You always at least have to add 2 things, the .git directory and your node modules directory. So that's step 1. Now, of course, in the recent years, we have had npm CI, and for your production stages, and we're going to get to multi-stage in a second, but for your production stages, you're only going to want to have your production dependencies. You don't want those dev dependencies in production because that's just going to add more potential for CVEs, more potential attack vectors, who knows. And it also adds bloat. So we're going to try to keep this slim. We want to make the security team happy. So in that production stage, we're only going to use CI with only production. The CI means that it will only install the app versions from the log file, which are the identical versions to the ones you just tested, right? So if you tested them that way, you don't want a potential npm install to change anything in your log file, which is why they invented the CI command. The next tip is to change your user so that you're not running as root. There's really no reason that I've seen, I think ever in Node at least, to run as root in the container. And so we can potentially reduce our attack surface by using user node. And I can say that because in the official Node images, they've already created a new user for you, calling it node. So in those images, you can just add user node. If you're using Ubuntu or distroless, you just need to add a couple lines to create the user in the group, and then you can change to that user. In this example, I'm starting from the bullseye image, and I am manually creating the directory because I want to control the permissions. So I make the directory and then shown it to the node, and then down here, after I change the workdir, I set the user node. But to do that, simply because how do you create a directory that only root has permissions to create with a user that's not root, right? So it gets a little bit wonky there, but those 3 lines are basically standard in all my Docker files. Now, in the copy commands, you notice that you're going to have to add the chown part, which is great. In recent years, Docker has added that as a feature. So I want to do that for any files I copy in. I want them to be owned by the node user. And I'm copying in my package and yarn files. Then I'm running my npm CI with only production, because this particular example is just creating a production image, not something for development or for testing with testing dependencies, but just there for production. And then I'm copying in my source code, and then I'm doing an npm start. Now, speaking of that npm start, we shouldn't be doing that. You shouldn't actually use anything other than the node process itself in the command, unless you're using something like tini, which is an init process. So node itself wasn't designed to really be the core starting process in Linux, known as PID1. And when you start something in a container, it becomes PID1. So in this case, what we're going to do is we are going to download and install tini, which is actually built into Docker by default, but we may not have Docker everywhere. So rather than running it through the Docker command, because you can do a docker run --init, but that's only temporarily on your machine, and that'll start tini first, which is a tiny little app, and its only purpose is to start other apps, and it will start Node for you. This does a couple of things. This properly handles signals coming from the Linux kernel, like, hey, you need to shut down. And it also prevents zombie processes, which are processes that lose their parent and thus go rogue and aren't able to be found and shut down in a nice way. So they're kind of known as zombies because they didn't die, they're sort of undead. And we want to do that. Also, it helps in exec probes. So if you're someone who uses Docker health checks, which cause a Docker exec to be used, or in Kubernetes probes where you're using an exec type probe, you typically want those probes to also use an init process for Node or really any other app, because those exec processes can sometimes get out of hand. There's actually a well-known talk from years gone by around zombie processes going crazy because there would be one created accidentally every time they did a health check, which, if you can imagine, throughout a day, lots of health checks happen. And the way to always prevent that is to make sure you have something like tini as your launch PID1. Now you can see me doing that in this image. In this case, I am just installing whatever tini version comes with the package manager. It may not be the exact latest, but they don't change rapidly, so it's fine that it might be one minor version out of date. And then I'm adding that as my entry point. What that means is that later on, I can just define my Node app, and then it's always going to be run inside of tini. I don't have to ensure that my command always includes tini and my Node app and its file. It can just be this setup here, and then all the way down at the bottom, you'll notice that we've now changed our command not to use npm because npm has issues. You shouldn't run that directly in containers as the launch process for servers because npm can't handle signals. It also is an unnecessary process. You don't need to have that additional process running on your servers. Really, we just want Node itself. And in this case, since tini is designed to be running in there, always starting and stopping and controlling our processes, reaping those zombies, then we want the node down here calling our app's main launch file. Now this gets to one of my favorites, which is multi-stage. And multi-stage is one of my absolute favorite features of the last, 4 or 5 years of Docker. And I have my own opinions about multi-stage. And the goal of my multi-stage is to have one Docker file do all the things, which does mean my Docker file gets a little bit longer. But I want my Docker file to be able to support development environments, testing and automation, and then true production environments. And those three have different needs, right? So we need to have a way to get our base together, all of the core essential things that are in common, and then diverge to a dev, a test, and a prod through stages. In the old days, we used to make separate Docker files for this, but now we got stages. And in this example, I'm only going to add a dev stage. So we're not yet going to add the test, which will come later. In this case, we're going to break it up into just dev or test. And you'll notice in this case, I'm sort of doing it all as one base there. And that base is not giving me dev first. What you'll notice is that I'm focused here on production. I'm adding in everything that I need for production, including my source files. I'm doing the npm CI with only production dependencies. I'm only adding tini in, and I'm running as the node user. So I'm doing all the things we just did, but I'm adding on a second stage. And that second stage here is adding the additional development npm install. It's changing my command to run nodemon, so I can do file watching for auto reloading on my local dev environment. And I'm changing the node env, of course, and that's going to do its own thing. So when I'm in local development using maybe a compose file, I'm going to target this stage when I build this custom image. And that is the image I would run locally. So it's my production plus my extra dev stuff. Now, why do I have this extra down at the bottom? Well, for a couple of reasons. This will work with old builders. If you use an old builder, like something that doesn't have build kit or buildx on it, then it will just build the Docker file from the top down. And I tend to like my images by default to always just build the safe production image. I only want to bother with dev when I really want to do dev. And that's usually a human building it manually with Docker Compose or something locally. So when I want it to be in any other environment, I definitely want production. So I will go back and reset the entry point and CMD down at the very bottom so that my production, when it processes top down, it finishes with my production stage. You'll notice that it goes back from base. It doesn't come from dev. So technically, when this production stage is built, there was never any dev in it. I didn't remove development dependencies with an npm command. I simply took the original layers that were identical to what I tested. In this case, we're not yet testing, but just imagine that. And I'm moving that to production, and I'm only changing the metadata, which is the entry point and the CMD. Okay, now we're adding more layers, more stages to our Docker file. And we're doing this so we can automate our testing. And in fact, if you look at this repo with all these examples, I did a talk recently, and in that talk, I talked about GitHub Actions and how you can automate testing and building and all the things, even with Kubernetes testing, automated in your PRs on GitHub. However, the way I approach this is I don't want this to mess up my production source. So again, we are going to layer testing stuff on top of those base layers that have all of my production stuff. I'm not going to muddle in the same stage with test and production. I really want these as separate layers so that I can skip them when I ship to production. And as you'll see in this file, we have the same original base, which only adds my production stuff. The only thing in there is the minimal I need for production. I am removing, by the way, from there, the source code. So we're not yet putting in source code. We're just copying in the lock files, and then we're installing the production dependencies. Then we have the dev, just like before. We started our dev. That's still there. So that's going to be used in our local machine. But we've got this new stage, and I do the source in its own stage. It comes from base, that very first stage, and it adds in our source. And the reason that I split this one out, and I document it here a little bit, but the reason I split that out is because I'm going to add test on top of this. I'm going to add more layers on top of this source. But when those tests pass, I want to go back to that line as what I'm shipping to production. I don't want to then do another copy of source code after the fact. I want a single copy of source code that I test and then ship. So that you'll see I do all of my test stuff here. I'm adding in my node modules from dev. So it's using the dev dependencies from that stage and it's copying them in, which includes those dev dependencies and node modules, and then anything else I might need. So I'm running an ESLint. Maybe I'm running an npm test command. I'm doing all that stuff here. And if that passes in my automation, then it will know to build my app again. But when it builds it, it's only adding metadata. It's technically going to come from source, which is this line up here. So it will start from line 29 and add 2 pieces of metadata. So technically what I'm shipping to production registries is the exact layers and files that I tested, not some other build variant or potential difference. I want to ship the exact thing. So I do this very deliberately to make sure that I don't introduce anything, even in the build stream, that I didn't test. All right?
Oh man, we ran out of time.
Thanks for watching. That's all I had time for today, but there's way more in the repo. There's more examples, just a ton of details in the README. Really just go check that out later. And of course, you can reach me on my weekly live show on YouTube at Bret.live, where I have guests talking about Docker stuff, cloud native stuff. I also have a Discord server with just hit 10,000 people for focusing on DevOps in a Discord server. So check on devops.fan. And of course, you can get my courses, coupons, other stuff, blog, all that stuff at bretfisher.com. So see you soon.